wondered how a camera works? How you can just point a box at an object, push a button, and suddenly there's a piece of paper with an image on it?
Well, I hadn't really thought about it. I always thought it was just some kind of magic. But that doesn't answer my question. What are you doing?
Well, I'm going to make a pinhole viewer, sort of like a pinhole camera, but with no film. Here, let me show you how it works. Most cameras have a lens to focus light onto film, or a sensor if it's digital. A pinhole camera is just a light-tight box with a small pinhole on one side.
Well, how does it make a photo?
Okay, suppose there's a tree outside and a laser pointer beam shines from the top of the tree through this tiny pinhole. It would make a spot of light on the back of the box near the bottom, right?
Right.
Now if the laser is shining through the hole from the bottom of the tree, where's the spot of light?
It would be on the back of the box, but on the top.
Exactly. But unlike the laser beam, light is reflected from all parts of the tree at once. So what you get is
an upside-down image of the tree on the back of the box. So you could put film there and make a photo.
Right. So what I'm making is a pinhole viewer, sort of like a pinhole camera, but with no film to develop. You need a solid box without cracks or holes for light to leak in.
But isn't there a crack there in that corner?
Yeah, sometimes there are cracks in the corners, so you should cover them with black tape. You also need aluminum foil, a sharp pencil, some tape, and vellum paper, or thin tracing paper from a craft store to make a screen so you can see the image. If you don't have vellum paper, then you can use wax paper. First, cut a small hole in the center of one end of the box. We'll call this the front. Cut a bigger hole in the back, and this is where your viewing screen will go.
So where does the pinhole come in?
The pinhole gets centered over the small hole in the front of the box. To make the pinhole, cut a piece of aluminum foil that's bigger than the hole in the box. Then take a pencil and gently press a hole into the aluminum foil and make sure that it's nice and round. And center the hole in the aluminum foil with the hole over the box. Okay, so now we need a viewing screen. Cut a piece of vellum paper and tape it over the bigger hole in the back of the box. Let's see if we can make an image through the window. No. Aim the pinhole toward a lamp and look at the viewing screen on the back of the box.
Oh, I see. There's an image of an upside-down bulb on the screen.
Okay, let's see if we can make an image through the window, but we should turn down the lights so that it's easier to see.
Huh, that's really cool. I can see the outside world, but it's upside down. So, I get how the image works, but how does it become an actual picture?
Well, if we were using this as an actual camera, we would put film at the back of the box instead of cutting a hole for a viewing screen. You would expose the film for a few seconds and then develop it in a dark room with chemicals.
How do you know how long to expose the film?
Well, there's some information on the web that you can use, but a lot of it's trial and error. Have you ever had a picture come out too dark or too light?
Ugh, all the time.
Well, that's a result of letting too much or too little light expose the film.
You know, I remember reading that you can use a certain type of pinhole viewer to make an image of the sun, like during an eclipse. The pinhole makes the sun's image appear on the screen, so it's safe to look at.
Right. And some photographers really like pinhole images because they're kind of distorted.
Awesome. Now I want to go home and try this out in my new lava lamp.
Oh, or that new purple party fluorescent bulb you have.
Well, I'm glad now that I know photography isn't magic. It's really science.
I'm Lydia.
And I'm Blaine.
And this was Exploring Pinhole Images.
Images.